News is when I was absent last Wednesday, I put us back a day. So your reviewing has to be more on your own, but I gave you the review homework last week. It was the amended day 6, and most of you turned it in, but some of you didn't do it. And that amended day 6 assignment that I put in day 6, that was a review for your exam that you would do for homework that day. So you're not missing any material, but you're missing the in-class review that we would normally do, which means you're gonna have to do that on your own, or I'm gonna have to squeeze it in the next 2 classes, and that's what I'm going to try to do. Okay, so today's lecture is a little short. It's one of the easiest lectures that we've had all semester so far. So that's the good news. And it's one of the shorter lessons. So that's good news. So that's why I can cram in this little review at the end. All right, today is all about vocab. If you've noticed, put your quiz away that you have on your desk. You gotta listen now, because this is real important stuff. If you've listened to my lectures for the last 7 class periods, I sort of baby talk to you. We talk about parenthesis houses, and we talk about, you know, a bad bird pecking at your house roof, and you gotta get rid of that exponent on the outside, right? I try to tell weird stories to try to help you remember. But today, I gotta be a big girl, and you gotta be big students, and we've gotta start going over the vocab. Because when you do your homework, they're going to use this proper vocabulary. So, I can't spell half the words, but I know them when I see them. So what you've got to do is you've got to know these words also. So if you look on my objective for today, vocab is a real biggie. So that might be easy for some of you, might be hard for some of you. But the bottom line is you have to start talking the math talk with me, especially if you're going to go into a pre-calc or calc class. They're not going to talk about birds pecking on your house roof like they did last Monday, right? All right, so let's get started, and I want you to listen real carefully. We got a whole bunch of people that's absent today. I hope I didn't give you all my bad cooties from last week. But if your partner's not here, turn around and talk to somebody, or, you know, you got to talk it, walk it, eat it, and drink it in order to learn it. So it's real important not to just sit quietly by yourself. Go find somebody else and just ask them if they agree with you, or if you don't understand, ask them to explain it to you. Okay, the first word, I'm going to teach you Latin today. Ugh. Latin, I can barely speak English. I can't even spell my English words. So now I'm going to teach you Latin. And so it's not real hard Latin, but it's Latin. Polynomial is your first key word that you need to know today, because the rest of this class is playing with polynomials from now until May. Think of polynomial as your last name. Okay, you have your last name, and then within your last name family tree, you might have your mom, you might have your dad, you might have some uncles, some aunts, right? But your main family tree is called whatever your last name is. So for me, it's Barbier. And within my family tree right here in Arizona, I have my husband, whose last name is Barbier, my son, whose last name is Barbier, and my last name is Barbier. So that's like the big general name of my family. Today, your big general name of your family is called the polynomials. In Latin, poly means many, and a nomial means term. So poly, you know, if you talk about poly threads or whatever in your clothes, you got cotton and you got silk and you got all kinds of threads in there. So poly means many of something, and a nomial means term. So polynomial is the big family name. Okay, how do we recognize this family? A polynomial can be just a coefficient, the number 3, and an x or y or q after it. This is called a polynomial. But also this big green box is called a polynomial too. The first box has only one family member. Do you see that? It's just 3x. How many family members are in the big green box? How many?
5.
5. How do you separate the family members? We separate it with plus signs and minus signs. That's different than last Monday's class. Last Monday's class, you were multiplying these little puppies together and you were dividing them. Today is different. Okay, so that's a polynomial. And this big green box is also a polynomial. It's the big family tree name. Now within your family tree, over here, you only got one member. There's only one person left in your family, Mr. 3x. The 3 is called the coefficient. I'm giving you vocab. And the x has an exponent of a 1, so that's called the degree of 1. You're sort of telling me how powerful is that one term. And we tell its power, how strong it is in that family by its exponent on the variable only. So I go to the next family over here. They're called polynomials too, but I have 5 terms. There's 5 members in that family. There's mom, dad, brother, sister, and a horse. I don't know, something's in that family. The first term has a coefficient of a 16, right? It's got a degree of 8. You're telling me how strong that family member is. He's got a power of 8. I go to the next family member. He has a coefficient of a -7, but his power is what? 6. You're just using your eyes. We're not using the calculator at all through today's lesson. You're going, oh, this is fun. I like this. Is there a lot of work shown? No, you gotta use your eyes and you gotta use your brain. That's what we gotta do today, eyes and brain. Okay, what's the degree of my second member of the family?
6.
6. You're just looking at the exponent and you say his degree is 6. Okay, my third term, what's the coefficient? 5. What's the degree? 4. You're telling me how powerful they are. How many of the x's do we have in that term? We got 4 here, 6 here, and we got 8 in the first one. Okay, what's the coefficient of the fourth term? -3. We got to put the sign with the digit also. That's called the coefficient. Its power is a 2. Last term, what's the coefficient? -4. What's the degree? 0. You don't have any variables, so it has a degree of 0. It's the low person in the family tree. Newborn baby. Okay? All right. So we just did all this. We said our degree is 8. The degree is 6, 4, 2, and a 0. From now on, when I ask you to write an answer down that's a polynomial, we have to write it down in what's called standard form. Standard form is writing the most powerful person down to the least powerful person. So this guy here is written in standard form. And I can tell that by the degrees. All right, now we're going to go back and do a little more Latin. If your polynomial, whatever I give you, that polynomial has just one term, its specific name is called a monomial. Mono means one. If you have mono speakers, you only got one speaker. Mono means one. If you have 2 terms in your little polynomial family, we call that a binomial. And a trinomial would be what? 3. Anything greater than 3 terms, we just call it a polynomial. It has no specific name. These 3 things we play with a lot for the rest of the semester. But this guy up here has no specific name. We just call him a polynomial. Okay, now I want you to work with your partner. Again, if your partner isn't here, turn around and talk to somebody behind you because they're probably by yourself too. How well did you listen to my vocab? See if you can fill in this whole sheet. Go. Talk it, walk it, eat it, drink it, smoke it. Go.
I think it's one. That's a good question. If it's just x to the sixth power, is that a coefficient of 1?
Write it down and I'll let you know in about 30 seconds.
Okay.
This would be 14. We added the coefficient, I believe. I mean the degree.
I thought it was, I was watching, I think you said it, because of every church.
You recognize this
I
flash?
think it was
Every time it's 7.
3, 1.
Okay.
That's
It's
what
the
I
same one.
that's what I thought. Coefficient. Yeah, I don't know. You don't add them. I don't know if you add them all together. Is it
Yeah,
all
I'm
B14
not-
or if it's all?
I'm not sure.
So we got 4 in it, and we have a negative coefficient.
Yes.
Oh, we got that one for 3. Degree of the whole polynomial, I think we're gonna add all the exponents together, so 7, 3, 1,
Yeah, I didn't ask for those. Degree of the whole polynomial?
No!
not 10.
11.
I think it's not. It's just
Who is the strongest person in that family?
11.
That's the degree.
Degree of the whole polynomial. It's talking about adding all of them together.
But
I didn't ever say add all these degrees together. Never said that.
Okay. But it's
I
saying the whole
said
polynomial.
whoever is the biggest, strongest in that family, that's the degree of that family.
You don't think
So our
it is?
degree is 7.
Degree is 7, all right. You're right.
like that's what you want to talk to me.
Now, any that you missed or you questioned, you should be
You take
circling
out last
it,
semester?
put a star by it. You should learn how to go from your mistakes. When I say go work with somebody or talk with somebody, if you have to ask somebody how to do it, or, hey, what do you think it is, or do you think it's a 1, or is it not a 1? Put a big circle around it and a star by it, because chances are I'm picking that as a homework question. I'm also picking it as a quiz question, and I'm also going to pick it as a test question when it comes to next Wednesday, when each question's worth 5 points, not just, 2 or 1 point. So your notes are for you, and you need to learn what you know and what you don't know. See, me listening to you when I said work with your partner, I'm listening to see who didn't get it, or who's doing something different, or what didn't I stress enough. That's why these front row seats are my best seats. They're telling me how to teach. I can't hear you guys in the back talking. I can't see your papers in the back, but I see their papers, what they're writing. Okay? So it's real important that you talk it, walk it, eat it, drink it, and smoke it. Don't smoke it. Right? But you gotta start talking this material, because the more you talk it, the more you'll remember it. You guys in the front row are gonna remember, I remember when she screamed and it scared the ever beavers out of me. Okay? All right, so any questions on the vocab? I'm sort of done with the vocab now, so that's as hard as it's going to get for today. That wasn't too bad, right? All right, but now we're gonna go into the math piece. And believe it or not, the math piece is pretty easy today, because our first direction, or first instruction you're gonna have is going to say to you, add these polynomials together, and you're going, holy bleep, what's a polynomial? Polynomial just means you got many things you're gonna be adding together. we've done polynomials before. When I gave you a 3x plus a 2x, and I told you to simplify that, and you put on your paper 5x, you were adding those monomials together, or this whole thing was called a polynomial, but when you simplified it, you gave me a monomial answer back. I didn't say those words to you then, but I can now. Do you understand? All right. So when they ask you to add two polynomials together, do you see the first parenthesis black house? And you see the second parenthesis black house? You have two ways to show me work. If you don't have Tim printing out your homework for you, you spoiled little things, all right? And you're looking at your computer screen or you're looking at your phone, I would show the work this way. If you've got to write your problem down. What did I do when I took the original problem and I did my work? What did I do? I lined up everybody that has the same power. Do you see that? I put the red guys underneath each other because they're both x to the thirds. I put the blue guys underneath each other because they're x to the twos. And I put the green guys underneath each other. And now I'm just going to add or subtract those coefficients. I've got a +4, +6. If you need your calculator, use it. But then we just put x to the third after it. We're not adding those exponents like we did on the homework last night, because the homework last night looked like this. It was 4x to the third times 6x to the third. And it was multiplying those two puppies together. Do you see the difference? Today's lesson is really the first day lesson. You're just adding your coefficients together. Over here I have a -3 and a +2. Well, I have more negatives than positives, don't I? I have 3 negatives and 2 positives. So I have 1 extra negative, and remember, it's either a -1 or you can just put -1.
10x to the third can't be like 1000x.
No, why?
I was just wondering if I needed to leave it alone in this case because of the x. I thought so.
All we're doing is adding our coefficients.
Yeah, I got that.
You're thinking it looks like this, 10 to the third. That's where your thousands come from.
I just wanted to make sure, right?
But that's not correct, because the math problem has an x to the third, not a 10 to the third. Is that okay?
Yeah.
Okay. All right. Then I go and I say, okay, I have a +2 and a -3. I got more negative x's than positives, and I put my -1 down there, and that's called simplify. Now, if you have Tim printing out your homework for you, or you print out your own, it's going to look like this on your paper, right? And it's going to say problem number 1, add this polynomial together. And I don't want to rewrite it. So this is the work that I do on my paper. Let me get rid of that line. And are we okay? Yeah. All right, so this is what I do. I underline the like powers. And then I use my eyes, and I say 4 + 6 is what? 10. And they all have an x to the third power. And then I go and cross them out like that. Because I want to see what's there, but I want to eliminate it so I can see, okay, what's my next powerful person? X to the 2's. Now I'm going to underline these guys, and I have a -3 and a +2. I have more negatives than positive. -1, x to the second, cross them out. Now I have a +2x and a -3x. They each are equal power. I have more negatives again than positives, so I have a -1. And that's what my work looks like. I'm not picking up my calculator. I'm using my eyes and I'm using my brain. Okay, questions on adding? I don't care which way you do it, it's up to you. If you're not printing out the homework, I would definitely do it that way when you gotta write it on your paper. All right, let's go down to subtract. What work do you have to show for subtract? Now listen carefully, I'm gonna take off a point if you don't do this. When you're subtracting polynomials, you have an extra step. Circle that in your notes. The extra step is that you have to change all of the signs in the second polynomial to its opposite. Oh, this is what happened. Let me go here. Where are we at? There? Yeah. All right. So what do we have to do? Look, you see the minus sign between the two polynomials? This guy in your notes, right, bad guy. He's a bad guy. Bad guy. And when you have a bad guy between your two polynomial families, the first thing you're going to do is change that bad guy to a plus. Because in math, we can only add polynomials together, we're not going to subtract them. We only subtract when we're really adding and the signs are different. Oh my gosh, why is math so hard? All right, so I changed this bad guy to a plus. See, now he's a plus sign, that's good. But you have to remember to change the signs of each of the terms in the second one to its opposite. So instead of a negative 3y squared, I need a positive 3y squared. Instead of a positive 4y, I need a negative 4y. Instead of a positive 6, I need a negative 6. That's the only thing you gotta do. So, let me show you what I do for work. Here's my math problem, watch. Maybe, extend the page. Here we go. Okay, so here's my original math problem, right? Tim's printed out the homework for me. Hallelujah, Tim. All right, watch. This is the work I'm going to do. Get rid of the bad guy. Take this guy to its opposite, this guy to its opposite, this guy's to its opposite. I don't do this stuff. How hard was that? Get rid of the minus between the two polynomial families. Look at the second one only and change it to its opposite. Now you can just add your powerful families. 3y, 7y gives me a 10y squared. Negative 11y, negative 4y, negative 15y. 8 plus neg 6 is positive 2. I have more positives than negatives. I don't pick up my calculator. All I gotta do is a bunch of pluses and minuses, and that's your work. This should be the easiest lesson of the whole semester for you. Okay, that's adding and subtracting our polynomials. Now today we're also going to be multiplying our polynomials. Believe it or not, I'm almost done. Multiplying our polynomials. Last Monday, we did that. That's a monomial right there. That was your homework that you're handing in for me today. Negative 8, negative 9 gives me positive 72. M to the 6, n to the 6, those aren't like, so I don't do anything, I just rewrite it. That was last Monday. That was your homework last night. That's your quiz today. But what we're doing today looks like this one in green. What's different? I put a plus sign or a minus sign between those two things. When you put a plus sign or a minus sign between them, the only thing you mess with are coefficients of like terms. Vocab. Coefficients, that's the number in front. Like terms has to have the same variable and the same exponent. So I have 7 of these purple, blue puppies here, queen to the 5th. And then I have 2 queen to the 5ths. Think of it as cards. You have 7 of them plus 2 of them. How many cards do I have?
9.
9 of those cards. I'm not messing with the exponents. Write that in your notes. Don't add exponents. This one is your homework, it's your quiz for today. There's no plus sign between those monomial terms. It's a multiplication, so we call it one term. This is 2 terms. Last night's homework was 1 term. I multiply the red numbers together. What do you get? 14 with your calculator or brain. And then now I mess with the exponents and I get q to the what? 10. Q5 just says how many q's you got in that math problem. You got 10 of them. Right? That's a review of what I just did on the last slide and what you did for homework. Now here comes the new multiply for you. I used to call it rainbow. When it was the first day of class, I said, you know, in Arizona here, I live in Arizona now, and it's like, boy, in Illinois, we couldn't even see a rainbow because it's flat and there's skyscrapers, so I never saw rainbows. It's like, is that a rainbow there? It's like, now in Arizona, I'm driving down 10 and it's like the most beautiful rainbows you see over the mountains when it's raining and blah, blah, blah. And it's like, oh gosh, I gotta call this rainbow. Because that's what it looks like when I drive home and it's raining. Beautiful sky, rainbow. First day of class, I said, you got a rainbow, this little 2 outside over each thing inside. Do you remember that? And you had to give me what for an answer?
6x minus 10.
Minus 10.
And that was hard the first day of class. You forgot how to do that first day of class. Now, let me go over what you're gonna do today. Today I'm gonna combine everything we've done in the last 6 lessons into one math problem. Really? Yeah. Now, instead of just a little lonely 2 on the outside, I'm gonna put a variable with an exponent out there. So you're gonna have to do a really pretty rainbow now tonight. When there's a monomial being multiplied by a trinomial. I'm giving you the vocab now. Mono means 1, tri means 3. Do you see that? You've got to give that monomial, the black 2x to the 4th, you got to multiply it by the red guy, the green guy, and the blue guy. Try it with your partners without me doing it. Huh? No fun.
2x times 2x to the 4th.
Do you do the homework that way too?
Yes.
No. Okay. What'd you get? Let's see. Did you get a 6? X to the 6th. See, some kids want to do 2 plus 3. No, we're multiplying the black number 2 times the red number 3. So I need a 6 there, not a 5. If you put a 5, do a diagonal cross through it, put a 6 up there, and then give yourself some notes, you know, and say, multiply, silly person, don't add them. But we do have to add the exponents, that's why you hate math. I'm multiplying, I get to multiply the numbers, but I gotta add the exponents, huh? That's math. Any questions on those three? How many got it? What happened to my middle row there? Huh? Are we okay? Do you understand? Back row, yes? Yes? Okay. Now we're gonna go to the hardest problem today, and I'm gonna show you the way the book teaches it. Don't take any notes, just watch. I'm gonna show you the way the book teaches it, and I'm gonna show you the way that I invented about, 5, 6, 7 years ago. And since then, my students went from a 50% pass rate up to about a 90% pass rate. You like that? Good
50
odds?
scared me.
Huh?
50 scared me.
That's right, because I used to teach it this way, and I made students teach it this way, and I lost you. So now just watch, don't take notes, because I showed you everything that's there. So you don't have to write anything, just watch and listen. This is the way the book teaches it, watch. This is a trinomial, do you agree, 3 terms?
I agree.
You got a red, a green, and a purple. And over here is a binomial that's all in blue. You see that? 2 terms. The book says take the red term and multiply it by the binomial. So that's what I did. Take the red term, multiply it by the binomial. I got to hand write all that. Then the book says, okay, now take the green term and multiply it by the binomial. That's what I did here. Then the book says, now take the purple term and multiply it by the binomial. That's what I did here. Now you gotta do 1 rainbow, 2 rainbows, 3 rainbows. Now you get all this, see all my pretty rainbow colors? Now you gotta sit and combine like terms. And this is your final answer. You write it in highest power to lowest power.
That's the same as FOILing, right?
No,
No, it's not the same.
but FOILing is my next slide, so you're almost there.
Okay.
This is called distributive. They're distributing this trinomial over the binomial. And you can't just do the first ones and the last ones. That's what most kids want to do. They want to say the answer is x cubed and then minus 20. As you see, that's not the answer. X cubed minus 20, there's a bunch of stuff in the middle. Kids don't want to do all that work. Because you know why? You make a stupid mistake at the beginning and your life is ruined. So, I came up with the box method. I just call it the box method. And so what do is I make a box. So on your paper, on your notes, I want you to make a rectangle, because we're going to practice making our own boxes. Make a box. I want you to have 3 columns. And then 2 rows. How hard is that? How long does that take you? Not long, right? Now, because we have a trinomial and then a binomial, that's why I have 3 boxes on top and 2 boxes on the side. You have too many boxes? Yeah, you're a 3 by 3.
Counted lines instead of rows
Okay.
and columns.
That's why you have to practice making boxes, see? All right, now we're gonna go over to the box I already made for you, because it's sort of perfect box, right? And what you're going to do is you're going to do 6 math problems that you did last night in each of these boxes. You don't use your calculator, you just use your eyes and your brain. And you're going to do the 8 rules of exponents that we went over last night. I have x to the 1 times x to the 2. You're doing length times width of each box. X times x squared gives me what?
X, that one.
X to the 3rd. Now that's exactly what we got up here in their mess. But I'm gonna show you, making a box and filling in 6 little blobs is so much easier than all this mess up here. This takes you half an hour, mine's gonna take you about 30 seconds.
Half an hour.
Yeah,
The
because you're gonna
distributed
make
property?
stupid mistakes along the way, it happens every time. All right, now take the blue X and multiply it by the 3X. Well, 3, and then what's X times X?
X squared.
So we have a 3 and we have an X squared. Your brain is just geared on your 8 rules of exponents while we're doing this. You're not worried about the distribution. You're not worried about rainbowing. All you're doing is multiplying length times width, length times width. Fill in the other 4 boxes.
Did I do that right? You think I did that right? But
How long is that going to take? As long as it takes for you to multiply little numbers together and then add exponents of the like terms. So you have a 5x here, a negative 4x squared here, a negative 12x, and a negative 20. However long it takes you to multiply numbers and then add exponents of like terms. It's that fast. Now, the unique thing of the box method is you have that great big line up there. So let me show you how I get my answer from my box now. I go through the boxes and I look at the highest degree. What's the highest degree? X to the third. I write that underneath it, and then I go like that in my box.
it's 3.
Now I go look for X to the 2's, and if you see, they're sort of always diagonally, and this always happens if you write them in descending powers. I have 3 and I have -4. What do I have more of, negatives or positives?
Negatives.
Okay, I have 1 extra negative, and I write that and I cross them out. Now let's go X to the 1. I got 5X, negative 12X. What do I have more of, negatives or positives?
Negative.
How many more extra negatives?
7.
Negative 7X minus 20. Same answer you got up there. Called the box method. It works every single solitary time. It brings my stats up from 50% passing to almost 90% passing.
Oh, I'm going. This too.
And the reason being is because when you fill in this box and you get a phone call or mom calls for dinner or spouse, girlfriend calls for dinner and you gotta go run to dinner, you can come back and you can see which boxes you haven't done yet and you can continue where you're at. But if you do it the book method and you don't write it out very systematically and very neatly, you come back after an interruption, the dog's barking, you gotta take the dog out to pee, whatever it might be. You go and you come back, you lose track of where you're at here. And you make stupid, silly mistakes. This one, you have to do 6 problems where you're multiplying the numbers and adding the exponents. That's all you gotta do. Then you combine your like terms from highest power to lowest power. It's just nicely organized for you. Okay. This is FOIL. You guys remember FOIL when you were in high school?
I used to wear it on my head,
You did? Why?
apparently.
Okay, does anybody know what FOIL stands for? Nobody knows what FOIL stands for? So FOIL is not aluminum foil,
Their
yeah.
last-
Okay, what is that? Your brain's got it. I've got 21 brains in here that don't have it. And it doesn't mean you're dumb, it doesn't mean you're stupid, it doesn't mean that you can't do the math. It's just, FOIL is an acronym, and I did this, boy, I taught 36 years in Illinois. For 35 years in Illinois, I taught FOIL, and I said, you have to know FOIL. And my percent rates dropped down to 50% every time. Why? Because some brains get it, some brains don't. So when I came out to Arizona, I said, I gotta think of something different. So I thought of the box method. So now watch. I'm gonna give you a math problem, and I want you to multiply it together. Look up here. Do you see this? It's a binomial times a binomial. Bi and bi means it's a 2 by 2 box you gotta make. So I put my x plus 3 on top, my x plus 5 on the side. It doesn't matter which one you put where, you're gonna get the same answer. Now, I want you to fill in these 4 boxes for me. Go. Gotta wake you up if nothing else. See, now you're gonna get kicked. Student abuse.
I hate circles, now I hate boxes.
You love boxes.
Okay.
Multiply, you add the exponents. Multiply, you multiply the numbers. Okay, what do we have for the first box?
X squared,
X squared. Next one across,
3x,
3x. Next one down,
5x,
5x. Next one down,
15.
15. How hard was that? It's 3rd grade math. You're adding 1 plus 1 to get your x squared. You're multiplying 3 times 5 to get your 15. This is FOIL. This is what I used to teach like this. FOIL, first, outies, innies, last. Guess what? This is first, outies, innies, and last. It's FOIL. Why books don't just do a box, I don't get it. Because some kids' math brains just don't get FOIL. But when I say make a 2 by 2 box, and you gotta fill in all the boxes, they get that. Again, you can go have dinner, come back, do the first box, and come back, and you know you gotta fill in 3 more boxes. You're not keeping track of whether you've done the first, the outies, and the innies. I used to have people come up on the front of the room when I taught this in high school, and I used to give them the first, and outies, and innies, and lasts, and we used to do a drama of it just to try to help them remember what FOIL was. And I thought, God, there's gotta be an easier way. So how about a box? You do this box method, it has changed my stats in this class. I went from 50% pass rate up to 80% pass rate. And because of FOIL, doing it by the box. You make less mistakes. You multiply the numbers together, you add your exponents. That's all you gotta remember. Now, if you're a good old FOIler, raise your hand if you love FOIL. No? Okay. If you're a good old FOIler, then I should see this work on your paper. I wanna see first outies and innies and last. Huh?
I don't know FOIL, I'm just.
Oh, good, okay. All right. If you don't like FOIL, then I should see the box on your paper. Then your answer is gonna be x squared, cross it out. You always combine these two, the innies and the outies. So you have 3x and a 5x. How many x's do I have? 8x, and then 15. And the word cute show would be something like that. So you're showing you're combining your like terms. Easy peasy?
Yeah.
Okay, try the first one up there with your group. I gave you the box, but now you gotta fill it in. How can I be so dang happy? You are really making me grumpy. Do you do that at home?
No, I'm thinking of too many things at once.
Multiply the numbers, add the exponents. That's all you gotta remember. Multiply numbers, add exponents.
With the average order, do I write those in?
Doesn't matter as long as
Oh, we want the largest of three first, yeah,
For your final answer, yes.
for your final answer, yes, okay. Oh. Okay. Above the box is the first set of terms? Okay. Yeah, that's what I was missing.
You guys are starting to make me grumpy. You're like 6 steps ahead of me. Again, if you want me to teach to you, you should be sitting in the front rows. I'm not picking up a calculator. I'm not doing FOIL first, outies, innies, and lasts. I'm filling in a blasted box. You gotta be able to multiply numbers
First,
together and add your
I'll write down
exponents.
that loan, higher degree of breaking lead.
Okay? Did you try number 3 already? You guys are 6 steps ahead of me in the front row here.
Is that it?
Does it matter which one you put on top, which one you put on the side? Nope. I don't care if you start going down first and then write the other one across. Doesn't matter. You're gonna end up with the same polynomial as long as you write it in standard form. Yep.
For number 3, am I given ahead? Should I wait before I ask?
Are you allowed to what?
Should I wait to ask a question about number 3?
No, go.
For the answer, would it be right for the minus PQ to be ahead of the minus 2P to the second?
You asked a very, very good question. He's saying, if I'm gonna write it in standard form, should I put all the P power or the squared powers first? And then put this little term at the back end, cause it's got the least amount of power? What you do is you put it in standard form, means you pick a variable, usually the alpha correct variable, so P comes before Q. And then you put it in descending powers of that variable only. So I have P to the 2, P to the 1, no P's. Yes,
Also, the minus 2Q should, or is it P?
P.
Though, it
It's
says
just,
minus 2P in a second, instead of Q.
You guys are really trying to get your extra credit, aren't you?
Should make it like 3.
No, cause you didn't have your hand raised. No. Okay, any questions on the box method? All right, look, what's different about problem number 2? Do you see a star by it? Problem number 2 has a monomial in front. You can do it a couple ways. You can multiply just the monomial over the first binomial here. Don't listen to me if you don't like math. The best way to do it is make box first. That's what I did here. And then multiply that 3x times the 3 terms inside. Do a monomial times the trinomial. If you multiply this first, you only do it to the first binomial. You don't do it to all of them. So it's confusing. So what you need to remember is when I give you a binomial and a binomial, make your box on that first, get your answer, and then do 3 times 10 is 30, add the exponents, x to the 5th. 3 times 3 is 9, add the exponents, 3 and 1 is 4. Yeah.
What if you had 3 binomials?
Very good question. If you have 3 binomials, you'll be in either the 151 or a pre-calc class. But in my class, you won't hit that. But if you had 3 of them, you would do 2 at a time. It's a very good question. If I gave you 2 times 3 times 4 and said multiply those 3 things together, what happens when I give you 3 things to multiply together? You go, oh, pick up my calculator, right? But if you didn't have a calculator, you just do 2 at a time, get an answer, and then multiply it by the 3rd.
So, 2 boxes, like first box, and then take that answer and make a second box?
I really don't wanna go into that, but I'll go into it very short. He's saying, what happens if you have this? Correct?
Yeah.
You're gonna make a box on this, and when you get your final answer, I just know how to do it a faster way. You get a 5x and a plus 6. That's your answer when you've done your box. Now you have a trinomial times a binomial. You gotta do this term times that, this term times that, this term times that. Or make a box that has 3 columns and 2 rows.
Thank you.
That was a pre-calc question, good for you. All right, ready? Ignore what he said. If you hate math. Everybody's going. All right, last slide. New material. These are called special boxes. You listening to me? Special boxes. What it is you have 2 binomials that look almost identical, but if I had you in the Math 92 class, I called these twins, but one's a boy, one's a girl. Can you see that? This binomial, girl, this binomial, boy, but they look a lot alike. They both have a capital A and a capital B, but one has a plus sign, one has a minus sign. So those are twins, but not identical twins. The other kind of special thing is when you have an A plus B, and that whole thing has a raised 2 outside. Well, that is identical twins, A plus B times A plus B. Or this is A minus B times A minus B. This is called a square of a sum, a square of a difference, or this is called a product of one being an add problem, one being a subtract, sum and difference.
The idea has me confused, I thought it was just.
Just wait, just wait, just wait, just wait. I'm gonna show you how to get these with our box method. Do you agree that these 2 guys look like twins? They each have a 2x, and they each have a 3, but one's a plus, one's a minus, one's a boy, one's a girl. What happens when you make your box? Right, 4x squared, 6x, negative 6x minus 9. When you have 2 binomials that look almost identical, but one's a plus, one's a minus, these boxes will always cancel out. They always do, because they're always going to be opposites. One is going to be 9x, the other will be negative 9x. One is positive 10x, the other is negative 10x. These guys always cancel out. So when I have what I call my boy and girl twins, I don't even draw a box. I just put 4x squared. I multiply the first 2 terms together. Then I multiply the last 2 terms together, and that's your answer. Because I know in my head that the diagonals, innies and outies, will always cancel.
So I can see them in the parentheses and just cross them out like that essentially.
Now, if you don't remember this little cute little shortcut, you can always do the box, and what will happen is these will start canceling out, and they do it all the time. So finally you'll learn that, oh, it's just the first box minus the last box. It's called a shortcut in math. Just like when your math teacher taught you in third grade 3 times 4, she used to say, what's 4 plus 4 plus 4? And you used your fingers or your toes, whatever it took, and you got 12. And she said, well, there's a shortcut. You can learn multiplication and do 3 times 4 is 12. Ooh, cool. And you get 12 without having to add 3 groups of 4. Well, that's what this is all about. When you start recognizing that you have, this is called a difference of 2 perfect squares. That's your answer. You got that by having 2 binomials, one's a girl, one's a boy. So, what's the answer to this one? Put it down on your paper faster than you can put your first name on your paper. Square the first terms, go ahead. Go ahead.
Like I apologized for earlier, I scheduled an interview student complete quiz. And
Square the
I was
last
really
term.
hoping to get my quiz done.
Okay. Square the last term. And what did you get? 16x squared minus 25? Did I show a stick of work? No. Really? You're gonna be a nice math teacher and I don't have to show a stick of work? That's right. When you have 2 binomials, one's a plus, one's a minus, I don't need to see work. I'm gonna assume you know the shortcut. Well, how do you know I'm not checking at the answers at the back of the homework? I don't. But on your exam next Wednesday, you don't have the answers written at the back. Then I'll know whether you know the shortcut or not. If you forget it, you make a box and you'll see the diagonals go off this correct. Okay, when you have a binomial squared, what makes this one so special? Well, if I put 2x plus 3 and another 2x plus 3, my first term is 4x squared, write it in. The second term is a 6x, and the one in the diagonal is exactly the same. It's another double of it. Always. These 2 diagonals will always be the same, and your last term is 9. So I don't show a stick of work on these guys either. Watch what I do. I take and I do 2 times 2x times 2x is 4x squared. Then I multiply these 2 guys together in my head. What's 2 times 3? 6x. You see how that's what I have here? And then I know I got another one of those, so I just double it. I just multiply what's inside the parenthesis house together and double it in my head. Not on my paper, not on a box. I get 12x, and then I multiply the last terms together plus 9. It's called a shortcut, not a stick of work. I can get the answers faster than you can put your first name on your paper because I know the shortcut. I'm teaching you the shortcut. If you practice it, you get good at it, and you don't have to show work. If you don't practice the shortcut, what you're going to have to do is this box every time, and eventually you go, oh yeah, here's these 2 boxes that are always the same. Well, how do I get a 6x? Well, 2 times 3 is 6, and put the x behind it. And I've got to remember that I got 2 of them. Okay? So that's what these are all about, is just practicing. Can you get those answers without drawing a box? If you can't and you go, I have no idea what just came out of her mouth, it scares me, I don't know, then you do your box or your foil, whatever you're comfortable with, and your homework's going to take you 2 minutes longer than my homework. Okay, let's see how well you listen. What's the answer to number 1? Raise your hand if you know it. Yeah.
100m squared minus 49.
Yep. You're going, how did he get that so fast? He recognized I have 2 binomials, one's a plus, one's a minus. The diagonals are going to cancel out, so he just multiplied 10 times 10 and put m squared after it, and 7 times -7 and put minus 49. Bam, he's got the answer, no work. Oh, the next one looks hard. What's the answer? Raise your hand when you got it. Come on, I got more than one person in the room. Yeah,
9r squared minus 1/4.
yeah. 9r squared minus 1/4. How'd he get that? He did 3r times 3r is 9r squared. A half times a half is 1/4. Don't panic when you see a fraction. Don't try looking for GCS and LCMs to get rid of it. You gotta keep those fractions there. But you just multiply a half times a half. 1 times 1 is 1, 2 times 2 is 4. That's third grade math. Now, this guy here, because it's got a little X out front, I'm gonna have to show some work. I'm gonna have to do the first part here where I have the two twins, and I get my 36x squared, and then I'm going to multiply everything by that x. So I'll write that on my paper, but is there any work to do? No. If you go from this to this without showing me my middle step, I'm gonna probably gamble that you just looked at the answers in the back. And you'll probably get it wrong on your exam next week when it's worth 5 points apiece. Yep.
I was looking down at my paper to repeat what you're pointing at from this to this one.
What was your question?
You said if you go from this to this.
Oh,
I'm
if you
gonna
go
see-
from this answer, here's the math problem on your test,
Okay.
and you, or on your homework, and you go to the end, I'll do a Las Vegas bet that you're just copying answers. It's your loss, I can't tell, it's your loss. You'll get your 5 points for homework, but you'll fail your exam. You gotta practice. You know, some of you, I know you're just copying answers from the back. If that's the way you think you're gonna succeed in this class, so be it. I'm not sitting in your kitchen table or at your den or wherever you do your homework and watching you. You're adult, I'm an adult, I'm trusting you. But where I see whether you're doing what you're supposed to is gonna be on next Wednesday's exam that's worth 100 points. See, all the points up until today, they're just junk points. If you get a 0 out of 100 on the exam, you're not gonna pass the class. And it tells me you're not doing your homework, you're just copying the answers in the back and trying to hand it in and scribble some crap out there. That's okay, that's what you wanna do, so be it. But I'm just giving you a little heads up. Okay, now I want you to take out your review for exam 1 that I gave you last week. It's a yellow piece of paper. Raise your hand if you want an A in my class. Okay, anybody not want an A in the class, raise your hand. Okay, that's good. Everybody wants an A. If you want an A in my class, you have to start doing this review sheet over the weekend now.